Welcome back to our section 4.4, Fundamental Theorem of Calculus. Today I want to review the trig and the exponential integrations. We've done all of these. There is nothing new except for that Fundamental Theorem of Calculus that we're going to throw in. So you should be able to work your way through these. I just want to give you kind of a refresher and give you a couple of examples to look at so you're not going into it necessarily all that cold. So just to review, here are the integrations of the trig that we know so far. There are more. We will talk about those later on. But right now, these are the ones I'm asking you to know. The integration of sine of x is negative cosine of x plus c. Cosine of x dx is a sine of x plus c. Secant squared, it goes to tangent. Secant tangent goes to secant. Cosecant squared is negative cotangent. Cosecant cotangent is negative cosecant. And then our new one, or newer ones, I suppose, the integration of a to the x. So we have a base to a variable exponent. That is equal to 1 over the natural log of the base times that base to the exponent. So notice, again, that base to the exponent does not change. All we're doing is changing what we multiply it to. The integration of 1 over x is the natural log of the absolute value of x. Remember, we can't take the natural log of a negative value. And then the integration of e to the x is e to the x. So let's go ahead and look at a couple of examples working with these. There's, again, not going to be miserable, but we are going to go ahead and play around with a few of them. So we have the integration from 0 to pi over 4 of 1 minus the cosine squared of x over the sine squared of x dx. So if we look at this, hopefully, I'm still hopeful, ain't I? 1 minus cosine squared, if we recall the Pythagorean identity of sine squared plus cosine squared of x equals 1, then if we rearrange this by subtracting cosine squared over, we end up with sine squared of x equal to 1 minus the cosine squared of x. Again, hopefully you're working with those note cards and you're studying them because they are going to be beneficial to you. 1 minus cosine squared, again, is sine squared, so we have the integration of sine squared of x over the sine squared of x dx. Sine squared divided by sine squared is, you guessed it, 1. So we're going from 0 to pi over 4 of 1 dx. The integration of 1 is simply going to be x. And we're going to go from 0 to pi over 4. Recall, we don't need that plus c because that plus c is going to cancel out. Even if we're working with trig functions or exponentials, that plus c is still going to cancel out for us in the end, so we don't have to worry about it. I'm going to plug in my pi over 4. So I'm going to take my f of pi over 4 minus my f of 0. Again, I'm going to put that 0 in just to show that I've got something minus, or my upper bound minus my lower bound, just so I can see that and I can mentally put that in my mind that I've done it. Not necessarily that you have to, but I highly recommend that you do. So we end up with pi over 4 minus 0, or pi over 4. And there's our answer. In example 2, we're going from 0 to 3 of 3 to the x plus 2 dx. Recall that we can go ahead and split this up if we want. So we can take the integration from 0 to 3 of 3x dx and add to that the integration from 0 to 3 of 2 dx. Some of you may like this form because you can see this more of an exponential and this is just a constant. Some of you are going to look at this and say 3 to the x, I know the integration of that. Integration of 2, I know the integration of that, and simply go into our integration, our antiderivative. So we can go ahead and integrate 3 to the x. The integration of 3 to the x is 1 over the natural log of 3 times 3 to the x. The integration of 2 is going to be 2x, and we're going from 0 to 3. Again, we could do the 0 to 3 on each individual part, but since they're both the same, we're going to leave it from 0 to 3. We're going to plug in my 3. 3 to the third gives me 27, so I get 27 over the natural log of 3 plus 6 minus, here we have to be very careful because now When we plug in 0, we don't necessarily get 0 out. So that's why I always kind of remind you to take that number and plug it in to see what we get. Because 3 to the 0 here is 1, so I get 1 over the natural log of 3, plus when I plug in 0 here, now I get that 0. So I get 27 over the natural log of 3 plus 6 minus 1 over the natural log of 3. I can go ahead and distribute that negative if you want, and 27 minus 1 gives us 26 over the natural log of 3 plus 6. And again, we could put this into the calculator. I expect that you could all throw it into the calculator to get the approximation. So I'm not going to necessarily go through that process right now, but I do expect that we can put that in the calculator and get the approximate value. And then finally, example 3, and then we're going to call it a day here. We have the integration of the sine of x minus 1 over x from e to 3 over e. So I know the integration of both of these individual parts. The integration of sine is negative cosine of x. Integration of 1 over x is the natural log of the absolute value of x. And I'm going from e to 3e. Marker's kind of bleeding there a little bit. So now I'm going to go ahead and be able to plug in my 3e. So I get negative cosine of 3e minus the natural log of the absolute value of 3e. And then from that I'm going to subtract, I'm going to plug in my e. So I get the negative cosine of e minus the natural log of the absolute value of e. And if this is an extended response, FRQ, I'm going to leave it. I'd probably put this in parentheses, but then I would probably leave it. I would be done. If it's multiple choice, what can we see with this? What can we do with it? Well, the cosine's probably not a whole lot. So I get negative cosine of 3e. Natural log of 3e. Think about the natural log of 3. What does the natural log of 3e mean to us? Well, we're multiplying 3 to e. So we have the natural log of 3 plus the natural log of e, don't we? Natural log of e is 1. So I get the natural log of 3 plus 1 there. So I can break this up into minus the natural log of 3 minus just 1 there. I can distribute this negative through, so I get plus the cosine of e, and in here I get the plus the natural log of e. Again, natural log of e, that's 1, isn't it? So I'm going to have here plus 1. Now, if I look, I have a negative 1 and a positive 1, so I can rewrite this as the negative cosine of 3e minus the natural log of 3 plus the cosine of e. And again, this is pretty much all I'm going to be able to do with this if it's a non-calculator question. If it's a calculator question, then we've talked about how to put this into the calculator and be done. Or you can put this into the calculator and be done. But this is probably going to be a non-calculator question, and you're going to most likely have to get down into this form by realizing the natural log of 3e can be simplified and the natural log of e over here can be simplified. So that gives you kind of a couple of examples, kind of gets you back in the swing of our trig and our exponential functions and being able to integrate those along with our fundamental theorem of calculus. So if you have questions, please let me know. Good luck, enjoy, and happy integrating.